Oh, we're getting back on the bus. So here we are in Jefferson Island, and this is Lake Peigneur.
Probably wasn't natural dissolution and collapse that happened over time. I'll come back to that. But what you saw and you probably have to come up close to see this, but in the video was that this well drilled right here, the Texaco State Lease 124 number 20, intersected a mine in the 1500 foot horizon and caused the collapse, and the outline of the collapse is shown on this right here. So this is out of Whitney Otan's book that you have a copy of. The mine shaft outline is from Dr. Locke's guide. We'll put them all together. The blue are the depth contours of the top of the dome. So right below the hill here, so it's only 100 feet below the surface. And then there's a 500 foot contour and the 3,000 foot contour. So this is the 1,500 foot elevation, which is the middle of the three elevations. This is a perspective diagram showing the different levels of the mining. So these are images of the collapse that you saw in the video, but the point of entry was right at the well, and then this whole area collapsed and lost a home and everything else they described there.
So just to get oriented, that took place, the drone rig went right over there, kind of up into that cove. And here's a trivia question for you. What's the deepest lake in Louisiana? Anybody hazard a guess? Lake Peigneur, 230 feet deep.
Now it is.
Now the rest of the lake is like 3 feet deep. But that particular area, which I think still holds a drilling rig, a tugboat, and 1 or 2 barges,
Oh man.
is 230 feet deep.
It's almost into the cut there. Is that where?
Yeah, see, this was the Jack Bayless home that slid off. All that's left was the chimney. But the whole house just slumped off into the lake. The mine shaft and the surface operations for the salt mine were over here on that other point. You can see some creosote pylons where they used to tie up barges to offload, but that's where the mine shaft was and the surface operations. So
did they shut down everything after that, I presume,
Yeah,
and it was kind of
yeah.
the end of...
unlike Avery Island, which was a controlled flood, this was definitely uncontrolled flood.
All right, we talked a little bit about oil and gas in association with domes. There's a pretty good publication here, which you can come up and see 2 profiles across the dome showing the outline in the subsurface, and then this one off the east flank shows the stratigraphy, the subsurface horizons, and then this is a subsurface structure map. So the contours are all dipping away from the faulted, cut up, dipping away from the dome. It's cut up by faults here. So these would be oil and gas reservoirs tucked up against the salt here, which makes for a really good trapping configuration. The dissolution, and Whitney Otan outlines this in his book that you got, which, by the way, the green book that you got is courtesy of the Louisiana Geological Survey. Ebola is a geologist with the survey, and we're very grateful for that. They are in the process of getting rid of all physical documents, so we're happy to have the survey providing those to y'all as part of this. But he describes the probable natural processes that caused the ultimate collapse in the formation of this lake. And he thinks it has a lot to do with the fact that this is a Pleistocene. It's not part of the current Mississippi river system, but a previous manifestation of a meander belt in here. And you can see some pretty distinct features. and he has it coming all the way out to here. So either the river itself actually cut into the banks of the island and caused the salt to dissolve, or there are always surficial aquifers associated with meander belt puffs. The point bars build up in the sequence and create surface aquifers, which are the primary drinking water aquifers in the Mississippi River alluvial belt. So at any rate, it was this relationship between the meander belt intersecting the dome that caused the original collapse of what was probably a topographic island. To me, the lakes currently on Avery Island suggest it was probably a progressive event in which water was seeping in, probably the surface aquifers feeding water in, and it gradually over time sunk. It was not a catastrophic collapse of the entire island. Currently there are two, Brian correct me and I didn't fix it before. There are two storage caverns which were created by the people, by humans drilling into the salt and dissolving. This is a sonic profile of one of them here. Both of these are used to store natural gas. And the significance here is these are all of the domes labeled here have some form of cavern storage. So there are close to 65 storage caverns in Louisiana. They use for everything from crude oil at the Strategic Petroleum Reserve at Bayou Choctaw to refined petroleum products at Sorrento. Exxon has a big facility there. They store diesel and other things here. But a number of them are, and they're listed here, are used for natural gas storage. So if you look at the oil distribution system in the U.S., there are huge facilities at Cushing, Oklahoma, and Patuca, Illinois, which have massive farms of storage tanks. And the idea is you have this network of distribution, production fields, and then distribution facilities that are taken to keep those in balance all the time and keep the right amount of the pipeline is possible. So storage becomes a really important part of it. There aren't tanks at the storage to store natural gas. So in Louisiana, salt dome caverns are used for that. And Jefferson Island is particularly well positioned because Henry Hub is the center of all natural gas distribution. The price of natural gas is quoted as the Henry Hub price, which means at the spot market, as oil is being traded, that price is determined at Henry Hub in, what's the town? Iraq. Yeah.
It's about 10 miles to the west.
So if a dealer was working between a buyer and a seller and had too much gas, he would be looking for storage. The storage on this salt dome is the most proximal to Henry Hub, so it's strategically positioned here. But all the green dots there are natural gas storage facilities that are part of the gas distribution system in Louisiana. And this is a diagram of Bayou Choctaw, which is the Strategic Petroleum Reserve. Last week, President Trump issued an executive order to start to draw down the reserves to mitigate the effects of the situation with the Strait of Hormuz. And so they're in the process of doing that now, but they also do store natural gas here as well. You want to just see that? It's there. In fact, if you zoom out, it's even more. More I could have. Yeah. There was a published geological map there that shows that.
This is a good. Is this in the publication?
Yeah, that's in OTAN.
Yeah, that's a great.
The only of the 5 islands that has a significant cap rock, which is anhydrite, limestone. They actually found sulfur here, and so back in the 20s and 30s. See, these are the 2 brown areas. So those were sulfur fields. They used the Frash method, drill down into the cap rock 600 feet or so, circulate hot water and steam to dissolve the sulfur, and then pipe it ashore. And I think that facility is where the natural gas facility is now, because I was here in the 80s. I was going to do a thesis on Jefferson Island, and I walked along the shoreline there, and you could find little pebbles of pure sulfur. It's very light, so it floats on the water, so it's like washed up along the bank. And then there was an area over there where nothing was growing. And I think they've now reused that for the compressor stations for the natural gas. So the sulfur extraction was in the 20s and 30s, and I think the first discovery well out here was in the mid to late 30s. So this is all pre-oil and gas.
This is Mike Kudak, and he'll be at the convention giving a talk here. This is his map on salt distribution in the entire Gulf area, and there are very definite basins here. The East Texas, Northwest Mississippi Basin, the Central Basin here, also basins in Mexico. And if you reverse the rotational opening of the Gulf of Mexico, these would be one at one time. This bulge right here is entirely lateral movement, illustrated here, in which the salt has been extruded out horizontally across here, and accounts for what's the Sigsbee Escarpment, which is the front edge of that. Most significant oil and gas exploration in the Gulf now is taking place below the salt canopy. Is that correct? So this was a question of getting the seismic acquisition and processing right to be able to image below the surface, and that's a big part of it now. You'll notice on anyone is that certainly we have this very distinct lineation associated with, but there are others. There's this line of dome right here, that's a good lineation here, and then a lineation over here. Jeff Spencer worked on this line of domes in particular, and he postulated a commonality between them based on a similar type of model here in the Lake Wilcox, in which salt was extruded and spread out laterally, and then the domes, and he has Gillis English Bayou. He has two of these domes here, extruding them. But the idea would be this body of salt came out laterally, and then you had this line of domes, all of which rose up from that lateral salt body. So you have the mother salt, an extruded layer, and then the domes come up from that. And the idea of this map here is that you can, and this is just my work, I've just been toying with it, but you can kind of draw circles around these clusters of domes. And I'm suggesting maybe that suggests there's a commonality to these domes based on that type of lateral extrusion model. I don't know that to be a fact, but I'm just throwing it out there.
They're kind of evenly spaced, aren't they?
Yeah, they are, and it could be tectonic. You know, one of the interesting things about the Five Island chain lineation is it's almost perfectly parallel to Hudak's Brazos transfer fault. And Brian Stevens with Bohm has postulated a whole bunch of these, and they would line up with the current axis of the Mississippi River, the Five Island chain, this one, and so that there may be some tectonic significance there. We talked about most salt domes being attached. This is one of the published seismic lines of South Louisiana. Dave Schuster Rochelle published this in the 1990s. But these hashered areas are salt. This is Valentine Dome and then the edge of Lake Murray. And what he's showing is a salt body with a weld connecting it to some deeper body, but it is completely detached. And so it was squeezed out and came up in that direction. And the origin of the salt relates to the plate tectonic configuration in the Middle Jurassic. So the rifting of the original rifting of the Gulf had just started. And at this point, the first time there was connection to open ocean circulate. So it was enough connection to the ocean to allow seawater in. There's a really good video at the BEG website by Frank Peel on that, and he has some very detailed maps of this origin. I think his takeaway suggestion was that once flow from the ocean started, there was a depressed internal basin similar to Death Valley today. So Death Valley is 200 feet below sea level. the Gulf of California is opening up, the Salton Sea is just, in a little while longer, if that chain opens up, it'll flow into Death Valley. And with that deep basin there, salt, just the evaporation cycle, if you're not in open ocean circulation, it can't keep up with evaporation and you start to precipitate salt. In that talk, he says, by his calculation, that's the fastest rate of sediment accumulation ever. That the accumulation of Luann salt was dramatically fast and happened in a really short period of geological time. And it's because it was a basin that was just accepting seawater and evaporating, and salt was just accumulating, both filling and subsiding at the same time, which I think is how you got to that level there.
Frank will be speaking on Tuesday
Yeah.
morning, too.
Okay. Yeah. So catch him. And then one more thing about dissolution, just an observation here. This is the map of the depth of fresh water across South Louisiana. So we have two massive aquifers, the Chico and the Southern Hills, which go down to about 3,000 feet. They both have a pretty distinct southern boundary, which basically coincides with the edge of the Salt Basin. Not uncommon to hear that the boundary of these aquifers is the Baton Rouge Fault System, or the Baton Rouge Fault System. That's not true, and I've conclusively determined that. There is fresh water on the south side of the Baton Rouge Fault System. What is more probable is that Jeff Peigneur at LSU, who will also be speaking at the convention, I think he's 85 or 86, but he is giving a talk on his calculation of lithium concentrations in salt. And he thinks it might be economic, so that'll be an interesting talk. But he has on several domes mapped out hypersaline plumes extending away from the dome, meaning they are dissolving and feeding into the superficial aquifers. And this is St. Gabriel Dome, which is right here. And so this saltwater plume. So what it's suggesting is this southern boundary is actually a mixing zone between freshwater aquifers to the north and dissolving salt domes to the south. And there's just a boundary formed at the edge of that mixing zone right there. And he's got some this is a really nice detail on it right here. But this is actually a map. This is just depth of fresh water. This is a map of salinity concentration. So he's actually showing his plumes extending from the dome. So, and around the area there are several domes that have lakes on top of the crest of the dome, suggesting that they're in some form of active dissolution. So, like I say, it's not uncommon to have a lake on top of the dome, but
Not in the dome.
right.
So is there anything in the geochemistry of the salt
Yeah, so there's a paper, Leslie Petrowska. I never exactly understood it, but they took samples from water wells in St. Tammany Parish, which is on the north side of Lake Pontchartrain, that had gone salty.
Right.
And they said they fingerprinted
That's right.
the
Yeah.
salt and determined that it was dissolved halite, not seawater, meating that it was not
Okay.
original pore
Like an
fluid.
isotope analysis
Yeah,
or something?
I'm hesitant to say much more than that, but they
Okay.
claimed
Okay.
they fingerprinted the salt and they thought it was hypersaline fluids, not the original pore water that would have come from
Interesting.
seawater.
It says, Lucas attempted to drill an oil well in 1899 and struck a free flow of oil of good grade, but abandoned the well due to poor tools and meager financial support. Now, how many times has it bailed on you because you got the tool stuff? Yeah, it goes back 120 years. So Walter Scott drilled the first Louisiana oil well, Jennings Dome, September 1901, 45 miles down I-10. Oslo Butte first oil was discovered that summer, the same year, September 1901. No, I'm sorry, September 1902, so less than a year later. We found much oil at 1,200 feet, spouting 25 feet above the derrick. And this is all courtesy of Jeff Spencer. He's He's a longtime geologist, been involved with the Petroleum History Institute forever, and he had a good write-up on Oslo Butte.
And
So
he's the GCHS historian.
GCHS historian, as he should be. So if anybody want a copy of that paper, I can email that to you. But that's from Jeff Spencer. So this dome's a little bit different. It's not really steep like the 5 islands, and this is maybe more common of the salt stocks. Chris spotted the. Let's go back to here. So this is the Cargill salt solution mining complex right here. They've got 5 injection wells right here, and so they're actively dissolving the salt, bringing it to the surface, using natural gas to evaporate it to crystal, and then mostly for table salt. Then right next door, with 1, 2, 3, 4, 5 storage caverns is Enterprise Products. Now they store liquefied petroleum gas, so butane, propane. So they're storing that here, which like natural gas storage, they'll release when the market conditions are right, and then fill it back up when need be. And they use a brine pond to fill the cavern as they empty the LPG out of the caverns. And this is what one of the wells looks like. They TD at I think right around 2,000 feet, maybe 300 or 400 feet wide. And then this is their process. LPG with a brine buffer underneath it, and as they pump the water in and out, they'll fill up the storage caverns. Their pipe program here, as you would expect, 1, 2, 3 strings of casing into the salt, and then this is off of Cargill's website of their process of how they evaporate the salt. Which through history, you know, you start reading about. I just bought a book by Mark Kurlansky called Salt. It's the history of salt. But as you know, for thousands of years, we need salt in our bodies. Every animal does. And so we've been finding these brine springs and evaporating salt wherever we could find them. And he did credit geologists of 100 years ago of finally saying, there's salt everywhere, man. You don't have to go to war over salt.
And there is a chapter in your guide. I love getting to come onto these big industrial facilities.
So can you hold up your box of salt?
Okay, here we are at Ants Lagoon.
Turn it around.
Oh yeah.
That's the front of the salt. So, okay,
So we're near Breaux Bridge, near Lafayette, Louisiana, and we're on the Geogulf 2026 Baton Rouge hosted Geogulf, and this is before the conference starts tomorrow, we're on a 5-dome field trip. So here we are right now at Ansel Butte, which is famous because it was one of the Patillo Higgins drilled here early, right after Spindletop. And right now there's a salt mine, and we have a lifetime supply of salt that's processed here in the plant. And we just had a very nice lecture by a guy who really knows the salt, and it's very pure, and they sell this. Cargill sells the salt mostly for industry purposes. But before getting here, we saw 2 other domes with very interesting histories out of the 5 salt domes on this field trip that are all in a line. Why are they in a line? Well, we've had some discussion about that. Deep-seated fault, maybe one theory, or perhaps it's just the edge of major sedimentary infill, and of course the loading of the salt created the ridge, and then the diapirs popped up. So here's, this is not, Ansel Butte is not a real formal diapir, but the other 2 domes that we visited are Jefferson and Avery Island are piercement domes, and so we got to see some of the mining operations that used to happen at those salt domes and a great history of salt in southern Louisiana.